One question can be, how many prime numbers are there in the first 100 natural numbers? So let's count prime numbers in the first 100 natural numbers. Okay, so what I've done is I've divided into groups of 10. Let me say, in the first 10 numbers, what are the prime numbers? 2, 3, 5, 7. In the next 10 numbers, what are the prime numbers? 11, 13, 17, 19. In the next 10 numbers, you can check. How would you check? I'm sure one that you are aware. The other thing would be that you can check the divisibility. You know, whether a given number is divisible by any of the other numbers or not. If it is not divisible by any of the other numbers, that means it is a prime number. As simple as that. For bigger numbers, we have method, but for smaller numbers, we should know, or we should just use tables to find. Yeah, and that's why I'm saying it is very important to identify all the prime numbers from 1 to 100, and keep them in your mind. I mean, they're like your name, address, phone number, like that. Okay. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. So 1 to 10, 11 to 20, 21 to 30, 21 to 40, then 41 to 50, 41, 43, 47, then 51 to 60, 53, 59, then 61 to 70, 61, 67, then 71 to 80, that is 71, 73, 79, then 81 to 90, that is 83 and 89. And very interestingly, from 91 to 100, there is only one prime number, and that is 97. Some of you may come up with the idea of 57 or 51 for that matter. Then you have 87, 91, 93. 93, it is shouting loudly that I'm divisible by 3, if you can see that. There is 9 and there is a 3. Zor zor se chilla ke bol raha hai, main 3 se divisible hu. To ye to nahi hona chahiye. 91 is in the table of 13. 13 sevens are in 91, so it is not a prime number. The rest of the 3 numbers, you can actually check the divisibility of 3. Are you aware that divisibility of 3 is dependent on the sum of digits of the number? What do? You add the digits. Say 51. If you add the digits, 5 plus 1, that is 6. If the sum of digits is divisible by 3, then the number is divisible by 3. So 51 is divisible by 3. 57. 5 plus 7, that is 12. 12 is divisible by 3. So 57 will also be divisible by 3. 87. 8 plus 7, that is 15. 15 is divisible by 3. For that matter, 9 plus 3, 12, that is also divisible by 3. So all these numbers are divisible by some or the other number. Hence, they are not prime numbers. Okay. Now, if we count them, in the first 10 numbers, how many prime numbers are there? 4. In the next 10 numbers, how many prime numbers are there? 4. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 3 prime numbers. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 3 prime numbers. Next 10 numbers, there are 2 prime numbers. Next one, the last one, there is only 1. Okay. So if I make the series, it is 4, 4, 2, 2, 3, 2, 2, 3, 2, 1. So in this manner, you understand, these are number of prime numbers in a decade. If I can use the word decade for 10 consecutive natural numbers like this. Okay, so in every 10 numbers, so first 10 numbers there are 4 prime numbers. Next 10 numbers there are 4 prime numbers. The next 10 numbers there are 2 prime numbers. In the next 10 numbers there are 2 prime numbers. Then 3, then 2, 2, 3, then 2, 1. So it becomes actually rhyming 4, 4, 2, 2, 3, 2, 2, 3, 2, 1. Now, what is the total number of prime numbers from 1 to 100? Either you add these numbers or you count actually from here. Whatever you do, you get 4 plus 4, 8. Plus 2 plus 2 plus 3, that is 7, 15, plus 2 plus 2 plus 3, that is 22, 24 and 1, 25. Or you can simply count 1, 2, 3, 4, 5, 6, 7, 8 and so on. So there are a total of 25 prime numbers. So total 25 prime numbers from 1 to 100. That's what we said, the first 100 natural numbers. First 100 natural numbers means from 1 to 100. So there are a total of 25 prime numbers from 1 to 100. Are we clear in this? There are a total of 25 prime numbers from 1 to 100. How many composite numbers are there? Can somebody tell me how many composite numbers are there from 1 to 100? Check karo. So I think 75, and I'm sure you are wrong. That it cannot be 75. Why? How many numbers are there from 1 to 100? 100. Out of them, 5 are prime numbers. And there is one number, 1, which is neither prime nor composite. So when you go on counting composite numbers, what you have to do is number of composite numbers. If I say composite numbers in the first 100 natural numbers, what do we have to do? We have to remove something from 100. What all do we have to remove? Total 26 we have to remove. Why 26? 25 prime numbers and 1 which is not prime, not composite. Total 26 numbers have to be removed. So the answer would be 74 numbers. So from 1 to 100 there are 74 composite numbers. So 25 prime numbers, 74 composite numbers and 1 which is not prime, not composite.